Welcome back from the ad break, and let's continue with our lesson. Let's look more at those application questions. So the first one here says, given the input values 1, 5, and 12, what will be the output values if the rule 2n minus 1 is applied? Show the output values in a flow diagram. So let's look at the rule that we've been given here. We've been given 2n minus 1. Now, remember our unknown value, that is the input value, and we've been given those input values. But now our input values firstly has been multiplied by 2, that's what gave us the 2n, and then after from that product we subtracted 1, and we now need to represent the output values in a flow diagram. Because 2 actions were taken, that means our flow diagram is going to have 2 blocks. Firstly, we multiplied by 2, and then after that, we subtracted 1. So we've been given 3 input values that we've been asked now to represent as output values after we've applied our rule. The input values that we've been given are 1, 5, and 12. And we are going to multiply each of these values by 2, and then we are going to subtract 1. So let's start. 1 multiplied by 2 is 2, and when we subtract 1, that is going to give us a 1. So that is our first output value there. Then we have 5 multiplied by 2, that gives us a 10, and when we subtract 1, that is going to give us a 9, and that is our second output value there. And when we say 12 multiplied by 2, that gives us 24, and when we subtract 1, that is going to give us a 23, and that is the output value there. Let's go over to number 2, which is a bit more complex, but as usual, I know that you can do it. We have there a given formula in a flow diagram, and we are supposed to find the missing input values, which is the P, and the missing output values, which is the T. So in this case, the P represents our input value and the T represents our output value. So we are going to apply the given formula just to fill out our flow diagram. Let's start with the first input value. The first input value there is a negative 5. Now look carefully at what happens to that negative 5. So firstly, the P there has been squared. So it means that P is multiplied by itself. So we are going to multiply the input value by itself. So that input value there is a negative 5. So negative 5 squared. And then that is going to be multiplied by 4. And then after that, we are going to add the 3. So what is negative 5 squared? That is 25. And when we multiply our 25 by 4, that gives us 100. And when we add that 3, that gives us a final answer of 103. So our missing output value there is 103. Then next we have a missing input value, right? So the first output value that was missing was that 103. Then now we already have the next output value. We need to find the input value. Now, how are we going to find that input value? Remember, we are going to work now in reverse, and we are going to make use of those inverse properties of ours. Now, the last thing that was done to that input value was to add the 3. So we are going to use now the additive inverse of a plus 3, and that is a minus 3. So when we say now 19 minus 3, that is going to give us a 16. So we now know that 4p squared is equals to 16. Now what does this mean? This means that 4 was multiplied to a number and the result was 16. So what number do we multiply by 4 and the answer is 16? Yes, we multiply by a 4. So it simply means that the p squared is actually equals to a 4. So p squared is equals to 4. So what number do we square so that the answer is 4? If you are thinking of 2, then you are absolutely correct. And when we check there, we are going to say, now this 2 is going to be squared. after it is squared, it is going to be multiplied by 4. So 2 squared is 4, and when we multiply it by 4, it does give us a 16. And when we add 3 to that 16, the answer is surely a 19. It means we are absolutely correct in our calculations there. But remember, when we are squaring numbers, we know that there is a possibility of a negative number and a positive number. In this case, when we said, what number do we square so that the answer is 4? Yes, you are correct in thinking of 2, but another possibility is the negative 2. So in the same way, if we say negative 2 and we square that negative 2 and we multiply it by 4 and we add 3, our answer is also going to be a 19 because negative 2 squared is a positive 4. And when we multiply that by 4, that is going to give us a 16. And when we add 3, that's also going to give us a 19. So in this case, we actually have 2 possibilities, and that is either a negative 2 or a positive 2. Let's move over to the next input. We have a 6 there. And now this 6, we are first going to square it, which we know is going to give us 36. When we multiply that by 4, that is going to give us 144. And when we add 3, that is going to give us an answer of 147. So when we have the input value, the calculation becomes much easier because we just follow the steps, or we just follow the formula that we have been given. What about the next one? Again, now we've only been given the output value, so we are going to work in reverse. So we are going to take this 327. We are going to use the additive inverse of a plus 3, and we are going to subtract 3. That is going to give us an answer of 324. Now, remember what this 324 is equals to. This 324 is equals to that 4p squared. That means that 4 multiplied by a certain number that is squared is equals to 324. But now what can be multiplied by 4 for the answer to be 324? We can do that by using the multiplicative inverse, and we can now divide by 4. When we divide 324 by 4, that is going to give us an answer of 81. So that means that a certain number squared is equals to 81. What is that number? Yes, it is either a positive 9 or a negative 9. Again, we have 2 possibilities here, and our input value can either be a negative 9 or a positive 9. Let's move over to the last input value there. We have a 0 as our input value. And that 0, we are going to square it and multiply it by 4. But we know that anything multiplied by 0 is going to be 0. So it just means that we have 0 plus 3, and that will give us an output value of a 3. And that is it. We have filled out our flow diagram, we filled out the missing input values, and we filled out the missing output values. Let's move over to our next application questions. We have a flow diagram there. Again, we need to find the rule, and we need to find the missing action there. But this time, we haven't been given a lot of output values. We've actually just been given the one output value. So we are going to use this one output value to fill out the rest of our flow diagram. So from the 9, we are going to apply the additive inverse, and we are going to subtract the 5, since as well 5 has been added there. And that is going to give us a 4. So from 4, let's look at our second input value there. We have 4, and we need to get to 4. So what do you think happened there? We can say we multiplied by 1. That could be a possibility, but we can also say that we added a 0. Let's check. If we say 4 multiplied by 1, that gives us 4, and when we add 5, that gives us a 9. But again, if we say 4 plus 0, that is going to give us still a 4, and when we add 5, that still gives us a 9. So we can use either one of these operations. Let's go over and fill out the other output values that are missing there. So we have 2 multiplied by 1, that will give us 1. And then when we add 5, that is going to give us, 2 multiplied by 1 is 2, not 1. 2 multiplied by 1 is 2. And when we add 5, that is going to give us a 7. But again, if we say 2 plus 0 and we add 5, that still gives us a 7. Then we have 6 multiplied by 1, and then that is a 6. And then when we add 5, that gives us an 11. But again, 6 plus 0, and when we add 5, that still gives us an 11. Let's go over to the last application question. And here we've been given a formula that says y is equals to 4x minus 2. And we need to represent this on a Cartesian plane. So there is our Cartesian plane there, and we've been given a value so that we can fill out our input values and our output values. So this time I've given you a small table. Why have I given you a small table? Because for us to represent our information on a Cartesian plane, we actually only need just 2 points. So you can extend your table and have more points there, but we can also just have 2 points in our table, and then we are going to put them on our Cartesian plane, and then we are going to connect those 2 points. So the input values that I am going to use here, I am going to use a -1 for the first one. So when I use -1 there, we know that we are going to multiply this -1 by 4, and then we are going to subtract 2. That gives us an output value of a -6. Because 4 multiplied by -1 is -4, and we subtract 2, that is going to be a -6. The other input value that I am going to use, I am just going to use a 2. And then for me to get the output value, I'm just going to say 4 multiplied by 2, that is 8. And then we're going to subtract 2, that is going to give us a 6. So let us write that into our table, and we only just need those 2 points. So if I am going to now fill out values on my Cartesian plane, then these are going to be the values there, 1, 2, 3, 4, 5. Remember, this is the horizontal one, which is the x values. And then don't forget to fill out the negative side as well. Although in this point, we just need the -1 when it comes to the x values. Let's put in our let me just put in the y values as well. I almost forgot them. So we know that the one that is going vertical is the y values. So 1, 2, 3, 4, 5, 6, and 7. And also going down, we are working with our negative numbers. So we are going to fill those out as well. And that is our -1, -2, -3, -4, -5, -6, and -7. And remember, there is 0 there in the middle. Just make sure that your Cartesian plane has enough values that the ones that you're going to be working with. Let me just fix here on the x-axis. As you can see, there are numbers that are repeated there. My bad. So we have a 1, 2, 3. There's a 4, a 5, a 6, and a 7 on the x-axis. You just make sure that you have all the values that you are going to need for your ordered pairs. What are the ordered pairs that we are going to be working with here? We are going to be working with a -1 with a -6. And also we have a 2 and a +6. So let's just go and draw those points there. We can also name them as P and Q. So -1 and 6, remember we start with the horizontal. We are at the -1, and then we are going to move down to the -6, and we are going to place that point there. That would be our point P. And then our point Q is the 2 and the 6, so that is the 2, and then we go up to the 6, and we are going to place that point there. And as you can see, those 2 points, if you take your ruler and just connect those 2 points, then that is going to be your graph. Again, I don't have a ruler with me here, but you must use your ruler to connect those 2 points. And that is our equation now represented on a Cartesian plane. Let's quickly go to an ad break and then we'll see you just now.